Let's be honest. We are born for a short time on a rock we call Earth, drifting through an ocean of darkness illuminated only by a nearby star we call the Sun. This star, a relatively young one in cosmic terms, formed in the last third of the universe's history, a faint ember from the vast fire of creation that has burned for nearly 14 billion years. Earth itself is merely a relic, a byproduct of that stellar birth, a fragile island in an endless cosmic sea. When you think about it, our existence is astonishingly brief and small. Most of the 100 billion stars scattered across our Milky Way galaxy were already ancient before the sun even began to shine. Compared to the grandeur and age of the cosmos, our human record is barely a flicker, a whisper of time. Yet within this tiny window of existence, something extraordinary has emerged: consciousness. We have evolved the capacity to ask questions, to look at the night sky and wonder where we came from, and to attempt to decode the story written in the stars. But this same consciousness carries a paradox. As much as it enables discovery, it also invites arrogance. The greatest obstacle to new knowledge is not ignorance, but the illusion of knowing, the arrogance of expertise, the conviction that our current models are final, blinds us to the unknowns that still await beyond the edge of understanding. True progress in science and thought comes not from certainty, but from humility, the willingness to admit that we might be wrong. When I was recently asked by a group of podcasters and reporters, among them Gotti Schwartz of NBC News and Elizabeth Vargas of News Nation, why Comet experts are so dismissive of alternative interpretations surrounding the anomalies of the interstellar object 3I/Atlas, I offered a simple analogy. I compared unimaginative scientists to artificial intelligence systems. Both operate within the confines of their training data. AI can only generate answers based on the patterns it has seen before. If you train an AI model solely on examples of comets, it will classify every object it encounters as a comet, even if the object behaves in ways that defy that label. Likewise, if a scientist spends a lifetime studying comets and nothing else, every new celestial mystery begins to look like just another comet, no matter how strange or unique it might be. This is why the interstellar visitor 1I/Oumuamua was hastily labeled a dark comet. It moved with non-gravitational acceleration, as if propelled by some unseen force, yet exhibited no visible gas, no dust, no tail, nothing that typically defines a comet. Instead of asking whether it might represent something entirely new, perhaps a relic of extraterrestrial technology, the experts chose to stretch old definitions until they broke, calling it a comet that behaves like no other comet known. Such reasoning is not science. It is a defense of comfort. When faced with the unknown, the mind seeks refuge in the familiar. Ironically, we already have examples of dark comets that we ourselves launched into space. NASA's 2020 SO booster, a piece of discarded rocket hardware, and Elon Musk's Tesla Roadster, both of which exhibit similar motions when illuminated by sunlight. These are clearly technological artifacts, yet comet experts dismiss them as irrelevant because they do not fit within the narrow boundaries of their training data. To acknowledge them as analogs would mean admitting that artificial or engineered objects can, in principle, display the same signatures. And that would open the door to uncomfortable questions that challenge authority, prestige, and decades of conventional thinking. This resistance to new ideas is not new. History is filled with examples of the scientific establishment rejecting discoveries that later became cornerstones of knowledge. Galileo was condemned for suggesting that Earth moves. Alfred Wegener was mocked for proposing continental drift. The Wright brothers were ignored by physicists who proved flight was impossible. In each case, it was not the lack of evidence, but the presence of ego that delayed truth. Science thrives on curiosity, but suffocates under pride. That same pattern of intellectual inertia plays out today. Comet experts observing 3I/Atlas have reported 7 jets emanating from the object, energetic plumes that could, in theory, be caused by the sublimation of ice pockets, as traditional comet theory suggests. But another possibility exists. Perhaps these jets are artificial, the controlled exhaust of propulsion systems belonging to a spacecraft of non-human origin. To even entertain such a notion is to invite ridicule. Yet dismissing it without investigation is equally unscientific. The purpose of science is not to defend a narrative, but to seek the truth, wherever it leads. When scientists become gatekeepers rather than explorers, they betray the very spirit of their discipline. Thankfully, there is still a path forward, one grounded in observation, not opinion. As 3I/Atlas approaches its closest pass to Earth on December 19, 2025, we will have unprecedented opportunities to study it. Instruments can measure the velocity and composition of its jets, analyze its mass density, and detect whether the observed fragments from its perihelion outburst are consistent with natural cometary behavior, or with something else entirely. Each data point will bring us closer to the truth. Science, when practiced with humility, is not about proving someone right or wrong. It is about learning what is real. On October 2nd to 3rd, 2025, NASA's Mars Reconnaissance Orbiter, using its high-rise camera, captured side images of 3I/Atlas from 29 million kilometers away, with a resolution of 30 kilometers per pixel. Though coarse, these images represent the first attempt by humanity to photograph an interstellar object passing near another planet. This achievement demonstrates our capacity to observe, but the interpretation remains open. The data are not yet complete. The story is still being written. Following this observation, an official letter was submitted to NASA urging further investigation. In response, Congresswoman Anna Paulina Luna publicly voiced support for continued study, recognizing the potential historical significance of the event. Her tweet was more than a political statement. It was a reminder that curiosity transcends boundaries. Whether one is a scientist, a politician, or a journalist, the desire to know what lies beyond our current understanding is a shared human trait. The coming months will be crucial. Instruments on Earth and in orbit will watch 3I/Atlas closely. If the jets behave according to natural physics, the case for a cometary origin will strengthen. But if they reveal patterns inconsistent with natural mechanisms, stable directional thrusts, non-random ejection velocities, or compositional anomalies, we may have to face the possibility that we are witnessing something unprecedented. In that moment, the debate between Comet and craft will not matter as much as the shift in our collective awareness. We will have glimpsed a broader reality, one that confirms that the universe is more complex and perhaps more inhabited than we ever imagined. To reach that point, we must first overcome our own limitations. The human brain evolved not to uncover cosmic truth, but to survive on the African savanna. It is biased toward patterns, stories, and tribes. We cling to familiar explanations because they make us feel safe. But science at its best asks us to go beyond comfort, to look at data without prejudice, to embrace uncertainty as the birthplace of discovery. When we do this, we become participants in something greater, the unfolding of the universe's own awareness of itself. Artificial intelligence offers a striking metaphor for this process. AI mirrors its training data. So do we. Both can become prisoners of their past experiences. But just as we can retrain AI on new datasets, we too can expand our intellectual boundaries by exposing ourselves to unfamiliar evidence and perspectives. The challenge is to remain open, to prevent knowledge from calcifying into dogma. The moment we assume we have all the answers, we stop learning. The arrogance of expertise is seductive because it confers status. To say I know is to wield power. To say I don't know is to admit vulnerability. Yet the latter is the true beginning of wisdom. The greatest scientists, Newton, Einstein, Feynman, all recognize that mystery, not mastery, is the essence of science. Einstein famously said, "The important thing is not to stop questioning." Questions are the engines of discovery. Certainty is its grave. As we await more data from 3I/Atlas, we should remember that the purpose of science is not to win arguments, but to expand understanding. The cosmos does not care about our reputations or our theories. It simply is. Our task is to listen to it with humility and curiosity. When egos take over, politics and social media turn inquiry into spectacle. But when we approach the unknown with open minds, science unites us. It reminds us that we are all seekers on the same tiny planet, orbiting an ordinary star in a vast and extraordinary universe. Perhaps that is the most profound lesson of all. The universe is ancient, immense, and largely indifferent, yet it has given rise to beings capable of asking why. To squander that gift on arrogance or denial is to betray our cosmic heritage. Better to face the mystery with wonder, to follow the evidence wherever it leads, and to remember that truth is not a possession but a pursuit. In doing so, we honor the greatest legacy of humanity, the courage to look up and ask questions.